this video, you will learn how to create a ROS2 publisher and subscriber in Python. We'll also step by step explain the code involved in it. So, first make a folder named ROS2 workspace, ROS2 WS. Inside this folder, make a folder named src. Now open the terminator and I will split the screen into some parts. Next, navigate to the src folder and we'll create a package. So just type ROS2 pkg, then create, and the optional parameter, this build type. So we'll specify build type as amend Python. So it will be a Python package, and then the package name. So we'll give it name PyTopic. Just press enter. And now you can observe that we have created this package with the default setting. So you can observe in this src folder, just open it and you can observe our default settings. And now we'll make a publisher. So just open text editor and here save this file inside src pytopic, then pytopic, and name this file as pytopic py, then pub, then spiral.py. Just save it and copy this file. Similarly, we'll create a subscriber file and change its name to py subspiral.py. Now go to GitHub and search ROS2 basics. Here select this link, ROS tutorial, ROS2 basics, and go to PyTopic, and again in this PyTopic folder, and then open this pypubspiral.py. So we'll understand this code. This import.sys, the sys library will let us take argument from the command line and use it. This time we'll take the message value from command instead of fixed value. Then this RCLPY provides standard Python API for interacting with ROS2. Then we have this geometry message. So since we will be using a topic of type, then we have this minimal publisher class which will inherit from node. We could have made this publisher and subscriber without using the class, but it's better to use class so that you can inherit it. That's why you will find the use of class in most of the ROS2 package. Then we have this constructor which will name the node as pypubspiral node. Then we create a publisher which will be of type twist and name it turtle1 cmdval. The timer is initialized, which causes publish message function to be executed twice a second. Then inside the publish message, you can observe that we feed the data and we take it from the argument, from the command line argument. and then here this line will ensure that every message is published to the console. So we take these 3 arguments from the command line, and then in main this RCLPy initializes ROS2. Then we make the object of minimum publisher class, which initializes the class and thus calls constructor. And this RCL spin starts processing the data from the node, including callbacks from the timer. So just copy this code and paste it in the pub spiral.py. Save it. Next, open the subscriber file py_sub_spiral.py, and as you can observe that it's mostly same. Like here we create a subscriber of the same topic and we print the message to the console. Even this is simpler than the publisher. Just copy this file and paste it here, and then save it. Next, go to the package.xml. So keep it always on top and open package.xml. Similarly, open the package.xml in this GitHub link. This package.xml, and we need to add these 3 lines because our package is dependent on this RCLPy, this geometry message. Since we are using a topic of type twist, which is of geometry message twist, so we need to add this dependency. Just save it and close it. Then open setup.py and similarly open the setup.py in this GitHub. Here we need to add this line, this console script line. So just copy this line and replace it here. So we have defined our executables, and now we need to build a package. So just navigate to ROS2 workspace directory and type callcon build. So build successful. Then we need to source our workspace. So here just navigate to our ROS2 workspace directory and then type source install setup.bash. Similarly, do the same thing here. So navigate to the ROS2 workspace directory and type source install and setup.bash. Now we can run our executable. So we'll run the publisher part. Before that, we will run the turtlesim node executable. Just type ROS2 run turtlesim, then turtlesim node, and keep it here. Now we will run the publisher which we have created. So just type ROS2 run, then the package name PyTopic. Just press double tab PyTopic, then the executable name which is py, then pub spiral, and we need to pass the argument. So I will just pass 2.0, 2.0 and then 0.2. The first is x value, second is y value, and third is the change in the angular velocity. So as you can see, our turtle is moving in a spiral, and similarly we will run the subscriber. Just type ROS2 run by topic package name and then the node executable name subscriber, and you can observe that it's properly subscribing. We'll close it and again run the turtlesim node. This time we'll pass a different set of argument. So now just pass 3, 1.0, then 3.0 and minus 0.2. Press enter. Now you can observe that our turtle is creating a beautiful pattern. It's because we are decrementing the angular velocity. So in the start it was 3.0, then we decreased it, then it decreases, and that's why the turtle is going far, creating a spiral. But when the angular velocity becomes 0, the turtle moves in a straight line for a moment, and then the angular velocity starts increasing in the negative direction. That's why we are getting this pattern. So that's it for this tutorial. I hope you like this video and learned something new. If you like this video, please give us a like and subscribe to our channel, and keep learning.